Today we are looking at how you can dilute a solution or add water, whatever your solvent is, into an already concentrated solution and make it less concentrated. So for example, if you had let's say a 10 molar solution, which is very, very, very concentrated and is usually way more concentrated than you would need for any reactions, you can add water to it and use that 10 molar solution for a lot longer amount of time, and you can use it in smaller amounts with a desired molarity that's smaller and more easily handled in an experiment. So that 10 molar solution that I kind of gave an example of is what we call a stock solution. So our stock solution is concentrated, and it's meant to be used in smaller amounts for in diluted solutions. So you can store it, use it in smaller amounts. So that you have it available and ready to use. And just by adding water, you are ready to go. And smaller diluted solutions. Okay, there we go. So when we talk about this stock solution, you're just going to want to add water to reach the desired molarity. And that is called a dilution, when you add solvent to decrease the molarity. For all of our purposes, our solvent is water. So if I ever say add water, I am referring to solvent in terms of our dilution. The moles of the solute does not change when a solution is diluted. If you think about it, if I have that 10 molar stock solution and I add water to it, my water is pure. It's not a solution of that same solute. So when I add the water in, my mole to volume ratio will decrease because I'm adding more volume, but I'm not adding more moles or amount in our molarity equation, and that's why the molarity will decrease. And also, as you dilute an aqueous solution or a solution with water, it will make it more transparent. So the coloring of the solution will also kind of become weaker. And if it's something that has flavoring, that will also usually make the taste, less strong as you dilute it down. And sometimes we use the word diluted, like metaphorically, and we'll say, or even just watering it down, right? You've probably heard that if there's like a hard truth and you're watering it down, making it a little bit less potent, if you will. Just other ways to help you remember, a dilution is adding solvent to decrease the molarity. Now, if you were to evaporate water, which is kind of the opposite of dilution, so we would be removing solvent, but again, the amount or the moles does not change, then our molarity will increase. Now, how do you remove the solvent? Well, you can heat it or you can leave it out to evaporate on its own. So we can do that by heating the solution, kind of boiling some of the water, and this will increase molarity. And again, it's kind of the opposite logic of dilution. If you take away some volume, now our ratio of amount to volume is going to go up. Molarity, this is a review term from last week. This is our measurement of the concentration in moles per liter. And we write it with a capital M. And so if you remember, capital M equals N over V. That was our equation where N is amount in moles and V is volume in liters. And so if we are to kind of rearrange this equation, I'm going to solve it for N by multiplying by V. So if I have this equation, I'm going to rewrite it, N equals mV. And this is kind of helpful because mV is going to be our amount of moles. But we have talked about already that our amount of solute is not going to change as we add water. And so the moles will stay the same no matter how many, changes we make to the volume and molarity as a response. So we can say that the molarity and the volume before water is added must be equal to the molarity and volume product after water is added, because the moles of solute are going to stay same. So that's like saying N before equals N after. We're just using it with this side of the equation, molarity and volume. So this equation, M1V1 equals M2V2, is really helpful for us to figure out molarity and volume relationships with dilutions. So let's look at example 1 so that we can make more sense out of what this M1V1 actually means. So if I have a beaker of 500 milliliters of water, and it looks like we're going to pretend that each of these blue dots is 1 mole. So I've got 5 moles over here. And you'll notice our moles amount does not change, 5 moles over here, because all I'm doing is diluting it. And the way you dilute is adding water. How much water was added to get from 500 milliliters to 1,000 milliliters? Well, the difference between those is 500 milliliters. So the only thing that has changed here is we added 500 milliliters of water. But this is going to affect both the volume and the molarity. And so if we take a look here, our initial volume is 500 milliliters. And our initial molarity, we're going to need this in liters, 0.5 liters. Our molarity will be 5 moles over 0.5 liters, which is 10 molar. So there's kind of like that concentrated stock solution, if you will. Then we add 500 milliliters to dilute it. Now we have 1,000 milliliters, which is 1 liter. And our molarity now is 5 molar. So you'll see our volume went up, which decreased our molarity since the solute did not change. It was still 5 moles as we added water. So our first one before was concentrated. And our second one after was diluted. Still fairly concentrated in respect to other solutions. 5 molar is pretty concentrated still, but it is diluted compared to what we started with. So the main idea here that I want you to see is that notice M1V1, if we were to multiply these two, is 5, and M2V2, 5. The amount of moles does not change, and that's why their product will be the same. M1V1 equals M2V2. Let's use this equation now for example 2 and example 3. And I have some beaker pictures here for you to kind of label, and these are in all of the worksheets that go along with this, this unit, or I guess this week of study. And I want you to label this side as kind of 1 and this side as 2. So M1 and V1 and M2 and V2. You have 100 milliliters. There's our V1 and a 2.5 molar solution. What is the new molarity if you add 400? Now before you write 400 in V2, we're adding 400. It's really important that you read the problem fully to get the correct answer. So if you add 400 milliliters of water to the initial 100, now our final volume is 500 milliliters. And we have all the information to plug into our equation. M1V1 equals M2V2. So plug them in. Got 2.5 and 100. 500. Now you might be wondering, why aren't you changing those into liters? You can, but if they're the same before and after, then it doesn't matter. So it's, as long as they're in the same units, you will get the correct units of whatever it is that you're working with. So if you want to turn them into liters, you can, but you do not have to for this equation. So solve for M2. I'll let you do the math. We get 0.5 molar. So there's our final molarity after adding 400 milliliters. And just as expected, it should go down. It did. Example 3. You want to make a 10 milliliter solution with a molarity of 1 mole per liter. That would be our final. So this should be 10 and 1 molar. If you have a 5 molar stock solution, what volume should you use and how much water should you add? So this time we're going to solve for volume 1. M1V1 equals M2V2. So we have a 5 molar stock solution. We don't know how much volume of that we need to use, but we know our final molarity needs to be 1 and our volume needs to be 10 milliliters. So if we solve for V1, we're going to get 2 milliliters. So to answer our questions here, there are 2 questions. V1 here is 2 milliliters, so we need to use 2 milliliters of the 5 molar stock. And then if we wanted our final solution to be 10 milliliters, how much of it needs to be added as water? Well, the leftover amount is 8 milliliters. That's what needs to be added to reach that final volume. So we'll use 2 milliliters of the stock and add 8 milliliters of water, and that will give us the final 10 milliliters at that 1 molar concentration. So a couple of ways you can use this to find the molarity of a diluted solution, or to find how much of a stock solution you need and how much water needs to be added in order to reach a desired molarity. Those are the 2 most common ways you will see this equation used. So on page 4, you have some practice problems using M1V1 equals M2V2 and solving for the variable you don't know. Make sure that you fully read the problem and see if it says add or, final volume or what amount. Don't just number hunt, because you need to actually use the correct meaning here in order to get the correct values. So you will usually have a number over the arrow saying how much was added or taken away. So don't forget about that really important piece in order to get the correct answer. So you do page 4 today, and then you will work through this dilution activity online tomorrow.